Thanks for coming, and sorry I'm late. So today we're going to talk about Foundry, a tool we've been developing with Paradigm and a bunch of other open source contributors. My name is Georgios, I'm the CTO at Paradigm, and I do a lot of open source work, among other things. So what is the problem? Because it's worth starting with the motivation. So if you look at how Solidity developers write their code, they typically go a lot from Solidity to JavaScript or Solidity to Python or whatever, and they spend a lot of time context switching. And the result of that is that you have a lot of libraries that get fragmented. Some are written in JavaScript, some are in Python, and you end up with a weak Solidity ecosystem of libraries, whereas ideally the language would have closed the feedback loop and you would have had many improvements in it. Now there's a trick here that anytime something takes, let's say, more than 15, 20 seconds to work, I'll tab Twitter and I'll start scrolling. So it's not 20 seconds, it's like minutes that you lose in productivity when something takes over some amount of time. And when you write your tests in a different language and you need to go over the wire like you do in classic testing with Hard Hat or with Ganache or with Brownie, what happens is that you get very, very slow performance. So it's important that we have something that's very fast so that we don't tab into Twitter and come back the next day. Security is obviously important. Mehdi gave some very nice motivations on how we should be doing security at the base layer. At the same time, the same technique for fuzzing, you can apply it for your testing environment. But the problem has been that, one, fuzzing generally requires too much setup, or it requires, basically the activation energy is non-zero, and this non-zero is enough to deter developers from using it. And also, when you're, in general, writing tests and you want to explore code paths, it's been hard to figure out how to modify state and to get mocks done, etc. It just takes a long time. So there's a bunch of problems, let's say, that make you less productive, and we're trying to fix them. And also, I don't know who needs to hear this, but I hate this library. All right, so just going very quickly through the solution. We write our tests in Solidity, one language, no context switching. We can use a very fast VM to get very fast performance over our tests, which are themselves written in Solidity. No Node.js or Python overheads. We can have a very fast compilation pipeline, which we customize. We parse the entire dependency graph. We can very smartly know whether a contract was changed or not and recompile it or not. Parallelize compilation across multiple different versions, parallelize across disjoint parts of the dependency graph. You can do a lot of cool things to keep making things faster. So this is what we're talking about today. So just to give some stats around why this matters, we have seen some interest by developers. A few big projects use it, and Lucas here says that they went from 30 minutes to 30 seconds, which is quite nice. Optimism also uses it in their code, MakerDAO, Soulmate. We have a GitHub organization. We have over 100 open source contributors in less than 6 months, which is very exciting about fostering an inclusive ecosystem. And what we do is that we let you write your tests in Solidity. And in every slide, I have a link to the docs for anyone who wants to follow along. So imagine that you have a simple smart contract like here on the left. The very simple thing that you do when you write a test is that you write a function prefixed by the word test, and then you write your tests. You say, this is the pre-state, what they expect. I make some call, what they expect. And if you want some failing condition, like the example here, which is obviously, 2 times 1 does not mean 4, the test should fail, so you write test fail. And there's other ways to do it in a more complex way, but we don't have time for that. Now, for property-based testing, which is what you will see tools like, for example, Trail of Bits, Echidna give you, is that the same way that we do unit tests, the same way we do property tests, or fuzz tests. But instead of having an argument, a function with no arguments, like here, what we do is that we simply add an argument, and the system will proceed to run the test over all possible inputs. And you can imagine, obviously, that this gets very useful if you need to find edge cases, especially in math implementations if you're doing DeFi. Now, we have something that we call cheat codes. There is a special smart contract deployed at a certain address, which you get for free if you use a certain library, which we also provide. And the cheat codes, they let you modify anything in the VM state. You can modify the timestamp, the block number, arbitrary storage slots. You can mock calls. You can check that some call will revert. It's very, very, very powerful. It's literally a hookable VM where you can inject anything to it. So you should check that out, and the docs have very detailed explanations on that. We have a very, very fast compilation pipeline, as I said earlier. So this is like me running a benchmark against Hardhat for 2 repos, which I consider to be reasonably complex. You will notice how, with no caching, the gap is whatever, and as there's more caching involved, the gap closes. No caching means there was no caching. A little bit caching means that you modified a file that was deep in the dependency graph, which means that a lot of things downstream need to be recompiled. And deep caching means that you just modified, one file at the edge, so 1 or 2 files were compiled. And you will also notice that there's a lot of overhead here relative to here, simply because the Uniswap repo is in TypeScript, and there's a lot of overhead into running the TypeScript code, transpiling the JavaScript, and all that, which, yes, we could benchmark without these overheads, but defaults matter a lot, and that's what the end user experiences. So we try to go with the default. We have very fast tests. As I said, compared to DApp tools, we have like over 20, 100, 300x, I don't know at this point, performance improvement. Against other hosted services, even like Block Native or Tenderly, we have, I would say, significant performance in like without any caching, with like when you use a local RPC node, or even when you have cached RPC responses. And we rewrote some tests on Hardhat for Uniswap Periphery, and we also got like 16 to 20x performance improvements for 2-3 tests. And this scales up as you have more tests, more fuzzing, because everything happens in parallel using a thread pool. So we have call traces, which personally I find is beautiful. You just write and it prints you all the subcalls that you have. It's blue if it's a cheat code. It's red if it's a revert message. It just looks nice and lets you figure out what happened in every subcall. We have an interactive debugger, which is a feature that many people have wanted for a long time. You write forge test debug, and it throws you in a drop. It throws you into an interactive debugger with source maps where you keep pressing down and steps you through the opcodes. You can see the stack, you can see the memory. And when you're doing low-level gas optimizations, it's very useful to know what's up. We have gas reports. This is standard. We've seen before from even the Truffle days. We have a single installer script, which you can run every day. Some people have done alias GM equals Foundry app because they just like to run it every day when they say good morning to the computer in the latest nightly release. What we're doing from here on forward is that we're going to make this even faster. The EVM that we're using, it is probably as close to EVM1, which is the fastest EVM implementation that exists in C++. We're going to make it stabler. Right now, we only do nightly releases because, candidly, we cannot bother. Like, we ship way too fast to do probably stable releases. New commands are coming, so scripting and deploying means that you write code in Solidity, and this generates transactions which you can post on chain. And that's very useful because now you can reuse the same code that you use for deploying in your tests. You can use it for deploying to mainnet. And you can test your deploy scripts, which causes, like in the past, we've seen that this caused issues in upgradable smart contracts, for example. We're adding Forge FMT and Forge Lint. You can imagine Forge FMT being what you would expect, like Go FMT, Cargo FMT. It's a formatter, so no more prettier. We're adding Forge Lint, which is gonna be, maybe it's gonna be like Trail of Bits Slicer, maybe not, unclear yet. Forge Doc is gonna be like a docs.rs. It's gonna be automatic code, automatic docs generation from NatSpec, but in a nicer way than what we've seen before. Anvil is the third tool in the Foundry toolkit, which is a Hardhat node or Ganache competitor. And finally, we're adding code coverage because you want to be seeing what your tests cover and whatnot. Invariant tests, which mean that I write a property and this property gets checked when the fuzzer starts firing at random functions on my contract, so you explore even more code paths. We're adding flame graphs, which are very important for figuring out gas optimizations and knowing where does your program spend most of the time, and more language support like Viper, Fay, and others. And that's it. I hope I wasn't like too rushed. So I appreciate the time, and I'm happy to take any questions. Yeah.
You need to simulate a call from an external address. Is that what that you would do with that sort of EVM? That
you can impersonate any account. So one VM cheat code that we have right here. Maybe I can click it. We have a VM cheat code which, how does it show? Okay, no IPFS. Okay, well, classic. Yeah, you can impersonate any account. There's a cheat code called prank, where you do vm.prank and you can become anyone. So, yeah. The cheat codes are very, very powerful. They let you do anything on the VM.
Yeah, hi. Probably going to repeat what I said to you on Discord a couple nights ago. But so I agree with all of this. I mean, most of the things are a no-brainer, performance and to the context switching and so on. But I also see a lot of value in the TypeScript tests, for example, for live documentation, and even for the designer, for the front-end developers to see that documentation and see how to learn themselves in the integration without even having to talk to me, which is happening right now while I'm here in DevConnect. Is the goal with Foundry? I mean, is this something that you may have a different opinion, or is this the goal for Foundry to somehow work together with Hard Hat, or to provide the ability to also have some other framework to provide these other kinds of tests?
You can run Foundry alongside all the other frameworks.
Yeah, I saw that a few days ago. I just wasn't sure if that was
it's an explicit
by
goal,
coincidence, or if it was actually...
It is an explicit goal to allow both incremental migration, so that, you know, if you have your Hard Hat tests, you don't need to delete them all and go to the other one, so you can just run them side by side, and that's fine. At the same time, you know, in smaller teams, you will indeed see, I think, this kind of thing that you said, where the backend developer writes tests and the utility function for the tests end up getting reused by the front-end developer. I think in larger teams, this does not end up happening. There's a clean separation between the two. Like the front-end developer will, I haven't seen many people that will use like all the utilities that you write in the backends. So like writing Hard Hat tests, like writing JavaScript tests, like for contracts is almost like being a front-end developer that writes backend, like you're writing front-end tests for your backend in a way, like whereas you should be a bit closer to the metal. And that might be a philosophical difference, right? So. I was mostly going to learning because in this case, front-end development are not as familiar, and I'm teaching them as they go. But if they're writing Solidity, they should probably be spending most of the time writing Solidity and not. Is that desired? I don't know. That's what I mean by philosophical difference.
Sorry to interrupt. I think we're spilling over to the next session. So I'm sure a lot of people have a lot of questions for Georgios and Foundry and all the related aspects.
I'll be around.
So Georgios is going to be around. Please find him. And thank you very much for joining us.